Hello and welcome to day 4. We have completed factoring, we have completed GCF factoring, trinomial factoring, we have solved using radicals. Now we are on to solving radical equations that are maybe cube roots and not necessarily square roots. So if we look at 2a, we're going to solve this radical equation. Notice that we have a plus 15 along with the cubed root, so we're going to do what we usually do and subtract the 15. Cubed root of 15 minus 7x equals 2. Now, we have to get rid of the cubed root. Now, usually if it was a square root, you would square both sides, so now instead we are going to cube both sides. We're going to get 15 minus 7x equals 2 cubed, which is 8. Subtract the 15. Negative 7x equals negative 7, and so x equals 1. You can go back and check again. How do you check? You put that into y1, put this into y2, or you can just plug in. 15 minus 7 is 8. The cubed root, try to do that the correct way. Cubed root of 8 plus 15 equals 17. And you're going to get 2 plus 15 does equal 17, so you're good to go. You guys need to have B done for class, so if you want to pause it and do B. Moving on to investigation 5, rational exponents, it says, consider the following radical expressions. How can these radicals be written in fractional or rational exponent form? We know the square root of 4 can be written as 4 to the 1/2. So how would this fourth root of 16 be written? Be 16 to the 1/4. Or 32 to the 1/5. Notice that the root goes in the denominator here. 81 to the 1/4 or 128 to the 1/7. This says, how can you reason to find whole number equivalents for each expression? How could you use a calculator? So what it's asking you is, what is the fourth root of 16? What is the fifth root of 32? The 4 tells you how many times it's going to be multiplied. What times itself? 4 times equals 16. Well, let's start with our smallest number that's not 1, 2. 2 times 2 is 4. 2 times 2 is 4, and so you get 4 times 4 does equal 16. So what is 16 to the 1/4 equal? 2. The same idea here, 32 to the 1/5 is how many is what number times itself multiplied by itself 5 times will give you 32. Well, we know this 2 to the 4th was 16, so 2 to the 5th will equal 32. Let's go to 81. We know this is not 2, it's not an even number. So what multiplied by itself 4 times gives you 81? Let's go to the next number up. 2 is 3. 3 times 3 is 9. 3 times 3 is 9. 9 times 9 is 81. So we know 81 to the 1/4 is 3. And this is 2 again. Moving on to the bottom of the page, consider the definition b to the 1/a is the 8th root, not the 8th, but the letter a root of b. And we know that when we raise a power to a power, which we could write it as this, we multiply the exponents. So how would you write 8 to the 2/3? Well, 8 to the 2/3 can be written with the power of properties, or we also can say that it's written as 8 to the 1/3 all squared. Or the opposite, 8 squared to the 1/3. Well, I know that 8 to the 1/3 is the cubed root of 8. And then all of that is squared. Or I can write it as this, 8 squared to the cubed root. 8 squared of the cubed root. So what we know is that the 2 is the exponent, the numerator is the exponent, while the denominator, which we know from above, is the root. The denominator gives us the root of the radical. So how can we simplify this? Well, I think that this one is easier to do because the cubed root of 8 is 2 and 2 squared is 4. Now we could have done it the other way, 64 and the cubed root of 64, and then we could have said 4 times 4 times 4 does give us 64, so the answer must be 4. But I think it's easier when the number is smaller inside. So moving on, says in working with rational exponents, one translation sometimes will be easier. So again, I think that 16 cubed is 4,096. The fourth root of that, we don't know that without a calculator, but I can figure out that what multiplied by itself 4 times gives us 16. Well, it's 2, and then 2 cubed is 8. I think that this way is definitely easier. What I would like you to do right now is pause the video and fill in this table for number 5. Let me do the first one. So radical form, I know that the denominator gives me the root. So I'm 125 cubed root of that, all squared. Well, I know that the cubed root of 125 is 5, and 5 squared gives us 25. So there are my two answers. Why don't you take a minute here, pause the video, and fill in the rest of the table. So we're going to move on to number 7. Rewrite each expression in radical form and evaluate without using your calculator. So I'm going to do 3 of them, and you're going to do 3 of them. I'll start with B. I'll let you do A, C, and E. So 27, the cubed root of that, and then all squared. So the cubed root of 27, let's see, 3 times 3 gives me 9, times 3 gives me 27, so that equals 3 squared, and that gives me 9. That's all you have to do. So let's see here, 8, the cubed root of 8, as 8 is in the denominator, all raised to the 5th power. So cubed root of 8 is 2, 2 to the 5th, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. See how I'm doing that? And 16th, 4th power, all cubed. It's 2 cubed, which gives me 8. Why don't you guys pause the video and try A, C, and E. And hopefully you got those answers. You can pause it if you need to. We're going to move on to number 8. Number 8 says, recall the definition of a negative exponent. Where you remember this from algebra. When you have a negative exponent, it means that whatever it's raised to moves to the bottom, to the denominator. Or if it's in the denominator, it actually moves to the numerator. So what we have here is we have a negative 4/3. We're going to write 1 over 1,000 to the 4/3, which we know is the cubed root of 1,000 raised to the 4th. Well, that's 1 over 10 raised to the 4th, which is 1 over 10,000. B, 1 over square root of 16, all cubed. And we know that's 1 over 4 cubed. And that's 1 over 4 times 4 is 16, 64. So the negative exponent, remember, moves to the denominator. I'm going to do the first one, and then I'll have you guys finish off the rest of the 5-4 class. So it should be done by the time you come to class. A to the n times a to the m, that is a to the n plus m. You add exponents when you multiply. So that is that. We are done with the day 4 notes, excuse me. Please finish up what you need to, and I will see you in class. Have a good day.